This video is going to be about line angle structures and why we use line angle structures rather than some other way of representing organic molecules. For example, Lewis structures. So drawn on the left is a molecule romidepsin that if you take organic 2 from me, organic 2 lab from me, you will probably have a chance to synthesize something that looks a lot like it. And as you can see, this is a fairly complicated molecule. There's a lot going on. There's some stereochemical stuff that we're going to talk about in a couple of weeks, where this bond is going back away from us as opposed to coming toward us, whereas this bond over here is coming toward us, and those matter. So which way bonds are pointing matters. In addition, we have things like several different oxygens. We have sulfurs. This is complicated. This is busy. This is very hard to look at and interpret, but it is a whole lot easier to look at this structure on the left than it is to look at this structure on the right, where all I've done is add in some, not even all, of the explicit hydrogens. I haven't done things like include lone pairs. This sulfur has 2 lone pairs. This sulfur has 2 lone pairs. This oxygen has 2 lone pairs. This nitrogen has a lone pair, and so on. I haven't included even all of the explicit hydrogens on this blue piece in particular. I haven't drawn many of the hydrogens that should be there. This is a nightmare to look at. This is pretty hard to look at, I'll admit, especially for people who are not yet used to looking at structures, but there's no way that this is a better way of representing the molecule. As soon as we start talking about complicated molecules, it becomes much less useful to use Lewis structures, whether they be Lewis dot structures or without the dots and just the Lewis structures, but drawing out the explicit hydrogens. It's such a bad idea that we will never do it again. From now on, I will simply represent the molecules I'm interested in doing as line angle structures, which is to say this thing over here on the left, and I will only draw out explicit hydrogens when I feel like they are important to communicate important information. I will, however, generally speaking, choose to draw out hydrogens that are bound to nitrogens or bound to oxygens explicitly, because that usually clarifies things. So OHs, NHs, SHs, things like that will be drawn out, but everything else will instead be doing these line angle shorthand structures. So line angle structures are just the best way of communicating a lot of complicated information in organic chemistry. Basically, every single one of these lines is a bond. So every single one of these vertexes is a carbon atom unless otherwise labeled. So if it's labeled with an oxygen, it's an oxygen atom. If it's not labeled at all, it's a carbon atom. I don't draw out the explicit hydrogens anywhere, so you have to just count up to 4 total bonds to a carbon in order to figure out where the hydrogens are. There are other important things that always happen. I will always draw out OHs explicitly. And there's another piece that you should be aware of, and that is that sometimes people like to draw Me for a methyl group that's bound to the end of one of these sticks. It's implied. If I don't draw anything else, this is a methyl group. Bound to that position is a carbon with 3 hydrogens bound to it. So a CH3 is the same thing as a methyl group. Or if I were to draw them out explicitly, I would say, okay, here are my 3 hydrogens, and I could either choose to draw a carbon at that position, or it's implied. Vertex is always a carbon unless otherwise implied. So these are all equivalent ways of conveying the same information. Methyl, drawing it out explicitly, or methyl drawn as Me. Which should you generate? I don't care. I don't care if you choose to draw out methyls this way or leave them this way. Broadly speaking, when I am working formally in writing, I tend to attach the methyls because I think they look cleaner. But when I'm doing things in lecture, I'll almost certainly draw them this way first. There's 2 real pieces I want you to think about when you're trying to use line angle structures. One is as you're trying to interpret them, and the other is when you're generating them yourself. When you are interpreting the line angle structures, I want you to pay attention to where the other hydrogens must be. So keep in mind that the whole idea with a line angle structure is to communicate both the lines, where the bonds are, and the angles. These are drawn, generally speaking, to show what the actual structure looks like. So if I want to draw, say, propane, the molecule, I will tend to draw it like that. Why? Because I'm trying to indicate a rough 109.5 degree bond angle there. Why does propane have a 109.5 degree bond angle? Well, this carbon has 4 things bound to it, 2 carbons and 2 hydrogens not pictured. Therefore, you know that this is tetrahedral. And if it's tetrahedral, you know it's sp3 hybridized, and you know it has a 109.5 degree bond angle. So I'm trying to indicate when I draw that. Let's draw a different molecule, like acetone. this bond angle here needs to be 120 degrees. Now, is there a meaningful difference between 1095 and 120? Yes, when it comes to the geometry of the molecule itself, it matters a lot. But when I'm drawing it on paper, I tend to use the same rough angles for both. This is the shorthand angle that looks right for both 120 and for 1095. But in any event, you're trying to show roughly what the molecule looks like. Both of these are correct. Meanwhile, if I draw a structure that looks like that, that looks wrong to me. And the reason why it looks wrong is because this has to be a 180 degree bond angle, which means if you draw something like this, it pains me a great deal. Never draw something that looks like that. If that's supposed to be a 180 degree bond angle, then when you draw one propyne, it should always have a 180 degree bond angle. Again, both parts of the line angle term are important. You need to draw the right lines, you also need to get the right angles. So, when you are drawing structures for the purposes of lecture, make sure that you're trying to get the angles correct. Okay, so let me fill in the explicit hydrogens in the middle of propane just to illustrate something. And that is, I would like those hydrogens to be here. Why? Because again, I'm trying to show a rough 109.5 degree bond angle. And okay, those don't look like 1095, so you could be a little bit more explicit and say one of those is coming toward us and one of those is going back away from us. But in any event, what you're trying to do is represent that this is tetrahedral, and that's the way I'd like you to draw things. So when you are drawing something, I would like you to draw with the right bond angles, about 120, about 109. Make sure that if you have something that should be linear, that you draw it as linear, and so on and so forth. However, when it comes to the interpretation of a line angle structure that I've already drawn for you, then I also want you to pay attention to bond angles and to not draw things that are total nonsense. You may be tempted when looking at a structure like this to put the hydrogen there when you're trying to add explicit hydrogens for something. However, that looks wrong to me. Don't do that. Instead, where would that hydrogen be? Well, if this hydrogen's going back down away and these are at 109, then the new hydrogen has to be coming out toward us. That looks good to me. That does not. By the same token, where's the hydrogen going to be at this position? Going to be toward us in some sense. Said another way, if we simplify the molecule and we're looking at propane again, don't ever draw the hydrogen here. That's not where it's at. This looks bad. We'll get big X's through it. Instead, your propane hydrogens need to be there. So pay attention to those little details of nuance as you draw line angle structures. But if you want to get good at line angle structures, all you really need to do is draw a bunch of line angle structures and or take structures that are already drawn in line angle structures and then draw the explicit hydrogens for them, making sure that you're not drawing bad bond angles, that instead you're trying to represent the molecule the way it actually looks.